study that we're giving you, you can find the brochure with all the information and also this link, which is very important for you to go to if you want to know more about the majors that you're interested in. And if you're undecided, you can also go here and explore the page to see the different majors, the classes that you can take, and everything you need to know. You can also start in 3 different periods during the year at FSU Panama, in fall, spring, or summer. Fall starts in August, spring starts in January, and summer starts in May. So if you're graduating in December, you can apply to start in spring of 2020. So you would have until October 31st to apply for spring. This is what you need when you're going to apply. The most important things being the TOEFL. If you're not an American citizen, if you're an American citizen, we only need a copy of your passport. But you do have to take the TOEFL with time, have your passing score to be able to start. And you have to apply online, which I'm going to explain a little bit later. The SAT, you can take the SAT, but if you haven't, you can do it while you're at FSU Panama as well. At FSU Panama, we offer the TOEFL exam that you can take at the English department, so you have to go there and find out what you need.
Yeah, so this is basically the deadline for spring 2020 for those of you who want to start in January. You would have till October 31st to apply, which is going to our website and filling out the application form. Very easy. You can do everything online. And then you would have to come to orientation in December to one of 2 dates. You would have to come either December 6th or December 13th. And then registration would be these dates. The first day of class for spring is January 6th. And if you want to start in summer, you have till next year, April 17th, to apply as well. So, at FSU Panama, for those of you who do not know, you need to complete liberal studies first before being able to get into any academic program that you're interested in. You have to go through liberal studies first, which is what you would do at FSU Panama, as well as prerequisites for your major. Your major is basically what you want to study: business, engineering, music, international affairs, whatever you want to study. And you also have the option of a minor. So the 2+2 scholarship program, for those of you who do not know what it is, basically lets you start at FSU Panama and transfer to Tallahassee main campus and finish there. But if you're eligible for the 2+2, you can pay as an in-state tuition, so as a Florida resident. It saves you up to $15,000 a year, which is a lot of money. You would basically have to start at FSU Panama and do 60 credits here, usually takes you 2 years, maintain a GPA of 3.0 out of 4, and be a Latin American and Caribbean citizenship. If you fill these requirements, you pay in-state at FSU Tallahassee. And that's where you see the difference in the cost. So instead of paying $21,000 a year, you would pay $6,500 a year estimate. And then how to apply really fast. That's our website. You would click on Apply Online, create a student number, fill out the application form, confirm that you're not a robot, and then pay the application. And then that's it. So a little bit of campus life at FSU Panama. We do have a lot of sports teams in different areas. And everything that you want. Once you start, you can sign up for any sports teams that we have. A debate club, volunteering program. So we have the environmental club. And more activities like the Lunch and Learn, which you're about to experience. And Club Fairs, where you can join any clubs that you want to join. And then graduation. So that's basically the most important information. Next step, take the TOEFL and apply online. Thank you.
attendance today. A very good welcome to students from the Inter-Oceanic Regional Panama who are visiting us today. You need to behave. I know you already, so I know how to behave. No chatting, no talking amongst yourselves. If you want to do that, you can leave just now. Okay? This is a university environment, so please behave. Welcome as well to our students from FSU. We have a wonderful occasion today where we have the privilege of listening to Olmedo Alfaro. Olmedo Alfaro has a wonderful and very interesting background. He's somebody who's devoted his time recently to promoting afforestation in response to Panama's very serious water shortage situation. Many of you, or some of you at least, might be aware of the very serious issue that we're confronting with water on the canal. Yesterday, the canal administrator gave a press conference and he was indicating some of the possible solutions, including damming a new river, including removing the salt from ocean water, and other solutions as well to confront the very serious water shortage problem that we have in Panama at the moment, which is quite paradoxical because Panama is a tropical country that receives large amounts of rain. So, Olmedo Alfaro has devoted his recent years to studying this project and coming up with a sustainable solution embedded within the concept of environmentalism and afforestation with tropical native species. Olmedo graduated from the United States Military Academy at West Point, New York, with a Bachelor of Science in Electrical Engineering. He subsequently obtained a Master of Science degree in Electronic Engineering at the Georgia Institute of Technology. He worked for many years as an executive at the Exxon Mobil group. Later, in Panama's public sector, Mr. Alfaro was a director of the Inter-Oceanic Regional Authority, PARI, the National Security Council, and the Panama-Pacific Agency. Mr. Alfaro has long been active in afforestation initiatives, including the STRI-led Agua Salud Project and his own Green Rain Project, Proyecto Lluvia Verde. Mr. Alfaro will speak for about 20 minutes. We'll have a couple of minutes subsequently for questions and answers, and I hope all of you take advantage of this great opportunity. Please, again, put away your electronic devices and no chatting so that we can all take good advantage of this unique opportunity today. Thank you very much. Mr. Alfaro.
See, I have to. Well, good morning. It is a real pleasure to talk to you de la Academia Interamericana, because I have a son who graduated from AIP. And when he tells me that he was very well behaved, I say, well, that's not too good. You have to more or less behave. Sometimes bad, not good all the time. But anyway, when we talk about the water issues, I'm an engineer by training. When we talk about the water issues, we have to come up with good ideas. And I like very much to talk to the millennials and below, because we rely on you people with your ideas and our work to move forward with all this water issue that Carlos mentioned, the water shortage. Well, as you know, the population grows geometrically, exponentially. It is not straight line, it is exponential. As the population grows, so does the water need for the population. And the only source of water that we have in the world of fresh water is the rain. The rain feeds the rivers, and the rain feeds the aquifers, the underground water wells. And that's where we get the water from, the rain. So we have to be very careful with rain management. And that is one of the reasons that we're lacking water because we're not managing the rain in Panama. So when we talk about rain, we have to look at 4 different aspects. First, do we have water? In some places in Africa, they have no water. So we have water. Second, are we storing the water for later use? If we're not, then the line stops here, and we have to store water. If we do not store water, we cannot treat the water. If we cannot treat the water, we cannot distribute the water. So right now, we're stuck in the storage process. If we have no water storage, we cannot treat the water. So looking at some pictures from NASA, from the Jet Propulsion Laboratory in Pasadena, California, a girl from Panama does this work for NASA. We realized that there are places in the planet that have water. The blue marks, or the blue parts, the blue paints, are places where there is water. Here you have the permafrost in Siberia. You have the glaciers in Canada and Greenland. You have the Himalayas. But then you have these green, big blue spots in the middle of South America and in the middle of Africa. Well, so happens that if we superimpose a map of where rainforests are in the world, we see that there is a direct relationship between forests and water. So the first condition that we need to have water is we need to have forests. So that brings us to the issue of forests and water. This is Panama in terms of freshwater storage. Very small compared to the rest of the countries in Latin America. But if we compare the water we have with population, water per person, then we're not that bad. But the issue, like Carlos mentioned, is that water availability is not steady. It's cyclical. We have rainy season, we have dry season. So we cannot divide the water by the people. We have to store water during the rainy season to be used later. How are Panama's forests? This is the trend of our forest over the last 100 plus years. We have lost 60% of our tropical forests. We only have 40% left. And that is coming down again, continue to come down. So if we run out of trees, if we run out of forests, then we run out of water. This map I wanted to bring to you is the Corredor Mesoamericano. The Corredor Mesoamericano was caught here by the Mina Santa Rosa. So animals cannot flow between the north and the south continents because the traffic was interrupted here. So that's another issue that we have to deal with. But going back to the forests, what is happening? Cattle raising is creating 90% of the deforestation because cattle raising here is very inefficient. So what happens? They cut down the trees, like they're doing in the Amazons right now. They burn it. Then we have that. Once we run out of trees, then the rain that is trapped by the trees, you cut down the trees, then you have mudslides because there's nothing to stop the water coming down fast down the slope. These are the 2 main rivers in Panama. The brown that you see is mud coming from water runoffs down the mountains, landslides, and the landslides are due to deforestation. This is Rio Chagres. This is where we drink our water from. And this is the main source of water for the Panama Canal. This picture was taken last month. And this is the Rio Santa Maria. The Santa Maria River crosses Veraguas, Herrera, Coclé, one of the main rivers. And that's where we draw our drinking water for the Azuero sector of Panama, Provincia de Azuero. So can you imagine, once you put sugar in the coffee, and your coffee is too sweet, how do you take the sugar out? How do you take out the sugar, the excess sugar that you put in? Very difficult. There are chemicals that we can use to separate the mud from the water, but that chemical, we also drink it. So that's not good to be drinking chemicals. The other issue that we're having now is the global warming. Because of all this deforestation, we're having global warming problems. Very, very hot air is coming from the Sahara Desert, going to Europe and going to America. Also, because of global warming, there is a lot of water evaporation in the ocean. So when those two masses collide, the hot air plus the saturated clouds of water, then we have very intensive rains, we have very intensive hurricanes, and those we can see right now, the threats of big hurricanes, like the one that went through the Bahamas and Puerto Rico, those we will see again in Panama also. This is la ciudad de Colón, Colón City in Panama, on our Atlantic side. Very strong winds coming land side, and those winds are very strong, and they create a lot of damage. And that we are starting to see that now more than before. That is also the Atlantic entrance to the Panama Canal. Very sensitive area to those type of water movements. Hurricanes we have here in this part of the world. In Asia, they have typhoons and cyclones. So whenever they tell you that we have a cyclone coming to Panama, that has to be fake. Because in Panama, we don't have typhoons, we have hurricanes. Hurricanes 1, 2, 3, 4, 5. Japan is going through now a very, very intensive typhoon, and a Panama flag vessel sank yesterday in the Tokyo Bay because of the typhoon they're having now. What is our proposal? So if we are concerned with water, we have to make sure that we maximize the capture of rainwater underground. So to maximize the capture of rain underground, and that's the purpose of my study, is that we have to produce a sponge or a mesh or a Swiss cheese underground, so that in those little tunnels underground, water gets captured. But the only way to have that sponge created underground is through biodiversity. We have to have insects, we have to have worms, we have to have all kinds of life underground, and that life makes those little tunnels, those little holes that we use to trap the water from the rain. Once we have the water trapped, then in the summer, on the dry season, that water goes down into the aquifers by gravity. We call that the sponge effect. This is the way we do our cattle growth, la ganadería. This is our proposal. We need to have trees that have long roots. Why long roots? Because we need to feed, we have to have the tree take food down to the underground to feed the insects. Now, how do we get food underground to feed the insects? Well, maybe you remember when you were studying biology, or botánica, mejor, botánica, they talked about the photosynthesis process. In the photosynthesis process, the trees take CO2 from the air and they transform CO2 into oxygen and water. Well, in that same process, the tree produces different chains of sugar. of glucosa. In that little chain of sugar, the tree also takes that sugar and transforms it into its sap, into its savia. The savia del árbol, it's the food of the tree, the sap. And that sugar is what feeds the insects that live underground, because that sap is taken down the tree through the roots, and that feeds the insects that we need to create the sponge underground. Because here, there's no sponge. It's all solid. Can you imagine 2,000-pound cow, because they weigh about 2,000 pounds, and they have 4 fingers, 8 fingers, 2 fingers each leg. Among those 8 fingers, they have to carry 2,000 pounds, and they compact the ground, so water cannot flow to the underground because it is compacted. So the tree takes the sunlight, CO2, produces sugars, and that sugar is sent down the roots. Also, the sugar goes into the leaves. That is why you see some insects chewing leaves, because the first place where the photosynthesis takes place is in the leaves. That's why insects like to eat leaves. This came out in BBC, British Broadcasting, and this is basically what we're doing. This was taken from the studies that we're doing here in Panama. So basically, what we're trying to do is create biodiversity underground to create a sponge. And that sponge attracts or traps rainwater. Now, what happens if rainwater doesn't get trapped? Because of deforestation, that rain erodes the topsoil, and the topsoil goes into the rivers. And once you erode the topsoil, then the land becomes sterile. You cannot grow anymore. So we're aiming at storing water here in the underground, so that in the dry season, that rain goes down into the aquifers to feed the deep water wells and to feed the rivers. These are some of the species that we're experimenting with at this moment with the Smithsonian, and these species are giving very good results in trapping rainwater. But none of this will happen if we keep deforesting Panama. Well, these countries in Africa, they have no water, so the only way they can live is by migrating to Europe. Because if you have no water, you cannot have any food. If you have no food, you cannot live any place with no food or water. So these people are migrating to Europe. according to the United Nations, in year 2030, in 10 more years, en los próximos 10 años, in the next 10 years, or in 10 years, the world will have a shortage of 40% of drinking water. Said in other words, in year 2030, 40% of the people of the world will have no water to drink. So we have to make sure that we do whatever is needed so that we have water to drink. Because once the mud gets into the water, and the mud from the deforestation, then it is very difficult to separate the mud from the water. Again, the places where there is water, again, the places where there are forests. So forests and water have to be together. You cannot have water with deforestation. And our study is aiming at solving the problems of these tropical nations. So our project encompasses 2/3 of the world population. So that is why the Europeans are interested in the things we're doing here in Panama. If you want to Google our work, you can Google sponge effect, Panama, or you can Google also Agua Salud Panama. And I wanted to show you this. This was taken about 4 days ago. It was sent to me by the World Economic Forum. These are the fires now in South America, especially in the Amazon. The red spots are fires that have 24 hours. And this is the rate of the global temperature increase because of the rain. Now, global increase represents el deshielo de los glaciares, the melting of the glaciers, water rising, and more evaporation from the oceans. More evaporation from the oceans represents more rain. More rains represents more erosion. So it is very, very important. It's critical for Panama to reforest, because not only for drinking water, because our Panama Canal is really, really threatened because of lack of water. Okay? This is my short 20 minutes.
Thank you very much for a brief and extremely informative talk. We are very grateful to you. So in summary, the project aims at creating the underground conditions that will permit rainwater to be stored there to supplement the aquifers and create conditions so that in the dry season there will be no water shortage in Panama. So could you put up the image of the 5 species that you have found to be more effective in producing this sponge effect, for the interest of our students and the people who are accompanying us as well, professors. So there's 5 species there that I would like to point out. I don't know the names in English. They probably don't have names in English, but they may have they will have scientific names. Is Professor Mirella here? Is she here? She's hiding. Okay, so our biologist is here. So it's cocobolo, almendro de montaña, amarillo, kira, and zapatero, the 5 species that the study has found to be more effective in producing this sponge effect that Mr. Alfaro has described to us. So we have a couple of minutes for questions. So those of you who would like to take the opportunity, would somebody like to participate, ask questions to our distinguished guest today? Any questions? I know Professor Leiva has questions. He always has questions. So
it's sort of, you know, every rainy season here, I just go, I get very upset because I see this tremendous amount of water. Sometimes, you know, you have flooding, and then, you know, a few months later, there's no water in Panama. And so I've always wondered, how come we're not damming more? How come we're not creating, you know, those dams to you know, have more water? There's a lot of mountains. There's got to be areas where we could dam the water. So that's one. For example, last weekend, this last weekend, I was in El Valle. The amount of rain that fell in about 2 hours was just unbelievable, absolutely unbelievable. And you know, and it saddens me to see this. It all ends up in the ocean, and then we are missing, you know, later on, then we don't have any water. So that is one concern. I also have another question. In my property, which has a nice slope, to control erosion, I created, you know, sort of little canals to keep the erosion from, you know, just taking away my land. At the same time, now that you're explaining this, I'm saying, you know, am I, or is the water that falls in those big storms enough, or the fact that I'm damming or taking out, you know, doing these canals at the end, ends in a canal in the street and then ends in a river, you know? Did I do well in doing that to control the erosion? Is the water that falls enough to percolate? So I don't know if I'm explaining myself, but in essence, there are two issues here.
There are a couple of things that we're working with that I personally, I do not feel too comfortable with building big water reservoirs, because big water reservoirs neutralize land that we need to feed for food, housing. So we have to, and that's the reason why we're trying to store water underground, because Lago Gatuna and Alajuela are deforming the growth of the cities, because you cannot live on top of the lake. You cannot feed or grow food on top of the lake. So we have to compromise between reservoirs and future housing for these kids' grandsons, because they will need land for housing and for food. That's one thing. The second, and before I forget, 87%, 87% of the rainwater goes right into the ocean without being touched by the human hand. So we're losing 87% of the rainwater. So our problem is not water availability, it's water management. We're not managing our rainwater. We're not capturing rainwater. So whatever amount of water you can store in your land is more than zero. So whatever you can do to store whatever amount of water underground is better. Now, if you drive to the interior and you go past Raihan, you see a lot of houses, I mean hundreds, thousands of houses. Well, if you see the roofs of the houses, the roofs touch one to another. Well, when the roofs touch one to another, the roofs do not allow rainwater to go underground, because the rainwater gets collected into a sewer and down the river. So we need rainwater to touch the ground, and the ground to absorb that rainwater. And to do that, the only way is to create a biodiversity underground, to create the sponge. Now, why is this interesting to Europe, what we're doing? I was in Norway last year. In Oslo, they invited me to talk about this project. They believe that they can copy our technology. Our Panama developed technology to implement in the South Sahara part. The South Sahara.
The Sahel.
And they believe that if they can capture some of the rainwater in Africa, in the South Sahara part, they will have water. If they have water, they have food. If they have food, then they stop import the illegal immigration from Africa to Europe. So what started with like a hobby here in Panama for us, it's a big issue now in the more developed countries of Europe, because they need to stop immigrants. And the immigrants move because they lack food. And they lack food because they lack water.
Very good. Ms. Quieta,
You just said that this started as a hobby. Is the government actually buying this and doing something about it? Are we planting all those trees somewhere in town? And
Well, the idea is to develop a very, very big project, a forestation project, to reforest Panama. I do not know if you're aware that the National Assembly created a committee to look at the disaster that we have in Darien.
right?
In Darien, we have no trees. It's a total disaster. Well, I was chosen to be in that committee. So my aim is not to look at the Darien part only, is to look at the Azuero part, the Bocas del Toro part, the Veraguas part, the Cocle part. We have to look at Panama as a whole. Because Panama is not only Panama Colón and the Panama Canal, it's more, a lot more than that.
Are you going to push for any incentives to people to plant those trees?
We already have the mechanism to do it. Unfortunately, well, Panameño have to say it. The only country in the world that is not interested in what we're doing, guess which country is that? Every other place in the world. I went to Japan, I went to Korea, to Norway, to Estonia, and everyone is very interested in learning about our technique. The only one is not Panama. So we have an issue there.
Do you have a question? Yes, there's a question here for you.
And the problem with big water reservoirs is then why don't you just build like in the streets of the houses, like you have more rainwater and create knowledge of
Well, any mechanism. See, what I just presented to you is just an idea. It's just what we're proposing. Anybody can make a proposal. And it's for Panama to decide which proposal they want to choose. The only reason, the only good thing about my proposal is that my partner, or the people managing the scientific part, are the world #1 scientific leaders in tropical forests, which is the Smithsonian. See, I am doing this with the Smithsonian. And worldwide, there's no one better than the Smithsonian. So that is what gives our work the A+ grade, because it is the Smithsonian that is doing this with me. This is not something that is being done without scientific background.
So how long do you think this is going to take for the government to accept it and make it a reality?
Well, the trees that we have planted right now have 7 years underground. And every month we calculate the water trap, we dig holes and measure humidity on the roots. It would take 3 more years to finish the 10-year study. But with the 7 years that we already have, we know with certainty that this will work. But we have not finished the number of years that the international qualifying authorities require for a study to be taken seriously. So we know that it will work. So the idea is to have Panama reforested completely, and we know how to do it. We just have to get the government involved. And as of today, seems that very few governments are interested in environmental issues, not only in Panama, worldwide. The environment, global warming, water is not a big issue for them.
Well, thank you very much, Ingeniero Alfaro, for a great presentation. For a couple of minutes, in case anybody's interested in talking to him, meeting him personally. Otherwise, we can have pizza. And at 5:1, the students from AIP will divide in groups to go to the 3 different classes that will be offered today. Thank you very much. Enjoy the
Jose. boy.